Hey everybody, this is Can't Stop the Unk, and I'm here with lesson 6. Alright, so before we begin, make sure you have a good understanding of what we've talked about through lessons 1 through 5. So that, because today in this lesson and for the next few lessons, we're going to go over like more complicated, higher level concepts. So without further ado, let's begin. So in the last video, we went over methods and we talked about static methods. So in this video, we're going to talk about non-static methods and how they differ from static methods. So you can see on the screen now it's slightly different, right? I have two views. So normally it looks like this. And in Eclipse, you can do something pretty neat, which is really useful. You can have programming side by side, which is what I like to do personally. And for the future lessons, more of these videos are going to have these double pane views, unless everybody complains. But I think this will really help explain things if you can see the code side to side, because this fighter class and battlefield class are related. So far, everything we've been doing has been between the brackets in the main method, right? So for this, before we go into non-static methods, we need first to go over what classes are. And I have two classes here. I have a fighter class and battlefield. And what those are is we're basically making a battlefield simulation, like a really simplified simulation of a battlefield with fighters. But what's an object? So objects and classes are closely tied together. And what an object is, it's called what we call an instantiation of a class. So we didn't go over this in the first 5 lessons, but so we'll go over what an instantiation is, or what are instance variables. Right here, you've been doing this the whole time actually. If you've done all the lessons so far, you've been actually using instance variables. Whenever you declare a variable like this, like an integer variable, HP, attack, and defense for example, and then you set it some value, right? Those variables are what we call instantiated. They're instance variables. These variables right here, HP, attack, and defense, are called instance variables of the fighter class. Like they belong to the fighter class. These HP, attack, and defense don't belong in the battlefield. They belong to the fighter class. So that's what we call instance. Instance basically means anything that belongs to the class. So for example, I have HP, attack, and defense. And you can see I put private here. And we'll go over what public, private, and protected things are in the next lesson. So just hold on for that. But basically know that anytime you have variables in here that belong to the class, that's what we call instances. So now that we know what instance variables are, now the question is, what are instance of a class? First, remember, an object is an instance of a class. Just remember that. So to know what an object is, we need to know what an instance of a class is. So whenever you make a new file, right, you can always create a new class by going into your folders and just hit right click, new, and you hit a class, right? And let's say we have a fighter, right? So maybe you want a wizard to add some variety, and then you have your public class wizard right here. And that's what a class is. So notice right here, it's really similar to when you declare instance variables. Instance variables have a type and then a variable name. So you can notice here that we have a fighter type because we created a fighter class with all these attributes. So when we create the fighter object, all you have to do is give it the fighter type. So instead of int, right, we can use fighter because we actually created this class. Now we have an instance of a class. So therefore, when we call this fighter basic variable, we call this an object because it's an instance of a class. We created an object, and that's what we call objects. So basically what a class is a template for object. It just defines what an object should be, such as what kind of stats do you want it to have if you're creating like a fighter, or if you're building a car, right, you might want to have parameters like gas mileage or how fast you can go from 0 to 60. So classes define those values, but an object is the creation of that class as an instance variable. So here we have the fighter class. What we call a fighter class will refer to this entire file right here. But when we say an object, we will refer to this variable called fighter basic. So now that we know what objects and classes are, we need to go over constructors. And constructors are really similar to methods. So now that we know what methods are from last lesson, we can go over what constructors are. Constructors set up what you want the object to be. You can see here I have new fighter, right? It's really similar to kind of like arrays when you have to say new int, because you're creating allocation space for that array. So here you're doing something similar. When you say new fighter, you're allocating space in your computer to create this object. So when I create new fighter, you can see that this fighter is going to have an HP of 100, 10 attack, and 5 defense, which is, these are variables I set up, instance variables that I set up for the fighter class. So when I create this fighter basic object for the battlefield class, they're going to have these attributes. And these are the only 3 attributes I'm considering for fighter. Again, this is a really simple basic example of this type of game, if you want to call it. So this is one way to build your fighter class with these attributes. Now there's another way you can build your attributes. Let's say you don't want every fighter to have the same stats, for example. Instead, you want to create a fighter with different stats for each fighter that you create. Then you can use the method overload that we explained last time, right? You can have these parameters, and Java knows which constructor you want to call based on how many parameters you pull in. So for example, when I create fighter elite, you can see I have boosted stats that I set as parameters here, 100, 50, and 20 versus 110 and 5. So this fighter elite is going to have better stats because I passed in these numbers as parameters. And you can see that I have this fighter. When I create fighter elite, it's going to use this fighter constructor instead of this fighter constructor. Now, a little thing that I want to go over before we move on are the parameters and how I set the values. So you can see that my parameters are called int HP, attack, and defense, which are exactly spelled the same as my instance variables for the class. So how does Java know which one's which? The way Java knows is that you have to use the this keyword. So when you say this dot, it will refer to these variables. So when I say this dot HP, it's talking about this. You can see it's even color coded. That has the same cyan, light turquoise color. HP, attack, defense is referring to this. And then you can see like the darker purple blue is referring to the parameters. So when you say this dot HP, it refers to the instance variables of the class, which makes sense because you're saying this. And what this means is actually referring to the class that you're in. So this dot HP means the variable in the class, and you want to set it to like 100, for example, right? Then the instance variable HP will be 100. So that's how Java knows if you're referring to the parameter or the instance variable of the class. So the last thing I want to go over are the syntax of a constructor. So it's very similar to a method. You have a declaration, whether it's public, private, or protected. Then you have its method, the name of the constructor, like a method. And then inside the parentheses, you can have no parameters, or you can have a bunch of parameters, right? And of course, you have brackets, and they're really similar. But the difference between a constructor and a method is that they don't have a return type, because when you create the object, there is no need to have a return type. You're not calculating anything. You're just creating an object. So for this reason, you don't need to have a return method, because the point of the constructor is to set up the parameters or the definitions of what you want the object to be. Now, a third way to set up your combat stats is using what we call setter and getter methods. But particularly, we're going to just first go over setter methods. So let's say you want to create a fighter object again, and this time call it fighter deity, and then we call it new fighter. So which means we're going to use this constructor, and fighter deity he's going to have these attributes. But currently, it has the same stats as the basic fighter, right? We use the exact same line of code. The only thing that's different is their variable name. So it's not a deity. So let's say you want to change its stats. So what you can do is set methods. And notice that this method is different from all the ones we've gone over in the last lesson. It doesn't have this static keyword, right? It has none of that. These are non-static methods. So whenever you have a non-static method, you don't have to put in any keyword. And you can see I called it set HP, and you can pass in the HP. And again, like within the last constructor, with this one, with the parameters, you put your parameter and you use this .hp so that the Java knows you want to change the instance variables, and you instead of referring to the parameter variable. So you set this .hp equal to the passed in parameter HP, and you can see that I'm setting the HP to 1000, attack to 1000, and defense to 1000. So now we have a deity because we call these three methods, and so the fighter deity object now has these attributes. We physically changed the fighter object to have these attributes. Before I continue, we should also go over that you can have static variable types. And the concept of using static variable types and non-static variable types is the same as methods. So let's first go over static variables. So here we have a static string, and we call the army type. Now you should note that static variables are often constant, because the concept behind a static variable or static method is that even if you don't create the object, or you do create the object, it probably makes sense to have some information to give back to a user, right? Or of the programmer. And constants are usually fit that bill. So let's say you want to know how many centimeters are in a meter, and that constant is always 100 centimeters for 1 meter. So before you even create any kind of object dealing with measurements, you don't even need to have an object to get that information. So no object and it's still useful information, that usually means it should be a static, and constants, they usually fit that bill. So let's look at this example. So let's go to the battlefield class, and you might wonder what kind of people could be on the battlefield. So before you even create any objects to place them onto the battlefield, you might want to know what type is a fighter, right? You might want to know if you create an object, before you create an object, you just might want to know the descriptions of all the people that could be on a battlefield. So we only have one type here, but let's say you had a wizard or like a whole class of men or types or women or anything that could be on a battlefield. But you don't want to create any objects, right? You just want to know some basic descriptions about them. This is perfect for static methods or for static variables. And that's what I did here. All you have to do is, you don't have to create an object like you did down here where you say new fighter, where you allocate space. You don't have to do that. All you have to do is say fighter, use the dot operator, and just call army type. Then you can just print out the string, and you just know what the army type is. And it obviously will print fighter because we defined the army type of the fighter class as a fighter. And then maybe you want to get the description. What is a fighter? So I describe the fighter as a battle-tested warrior, trained since childhood, destined to serve his land. So even if you don't create the object, you still might want to know what its description is. Therefore, it should be static because it's a constant. No matter how many fighters you make, it's going to have the same description, even if they do have different attributes. So when you call fighter dot description, you don't even have to create the object. You just say fighter dot get description, and you can just print out the description, and it prints it right here. Now let's go to the non-static methods, like the setters, getters, and change methods. Let's say you never create a fighter object, it doesn't make sense to have set HP, set attack, set defense as static, because you didn't even create an object yet. So what are you going to set the HP of a thing that doesn't even exist? So that's why these methods down here are non-static, because in order for them to have any meaning or any use behind, like the methods to have any use, you need to have an object in the first place so that you can set these attributes for the object. And that's how you know, that's the rule of thumb you use to determine whether a method should be static or should be non-static. So to quickly summarize, static variables or methods usually deal with constants or things that don't change, or it doesn't matter if you don't create the object, it still has useful information before you even created anything. And then use a non-static method when it's only useful if you create an object and you want to like change its attributes or do something with the object itself. That should be when it's non-static. Alright, so that's it for this video. In the next video, we're going to go over into more detail about the fighter and battlefield classes, and we're going to talk about the dot operator and where it comes from, how it actually works, and why when you do the string, for example, with the string manipulation lesson, when you hit the dot operator, it brought up all these methods. So that's what we're going to go over next time, and probably also public, protected, and private variables. So I'll see you then.